Assalamu alaikum and welcome back to my YouTube videos. And my name is Arslan Rizwan. I am a student of Mechatronics Engineering from Air University. So in the fourth semester, I was given this project of line following robot with some additions to it. And this is the final project of our microcontroller and embedded system. In this project, the group members included have the roll numbers 221721, 221739. The supervisor was Sir Umar Farooq and engineer Sadia Said. So over here I show you the number of words in this document that were written from Arslan Rizwan's side and from the side of Sibgha Jilani. She was the lead and Arslan Rizwan was the technical manager, or you can say the product manager, who was the manufacturing manager. So first of all, we acknowledge Sir Umar Farooq and Ma'am Sadia Said for this opportunity and for helping us out through this project. This project was assigned to us on 17th of March and was to be submitted within the 4 weeks. But there were some additions, so it took more time than expected. The table of content shows the points that I have in this report, such as the preliminaries, which include initial feasibility, technical, and team roles and details, work best, and such. All these headings are further defined in this report, and you will see all these in a few minutes. Yes. So first of all, this shows a proposal that the main aim of our project was to make a line following robot which had two DC motors, okay, and it was supposed to follow a line. Basically, a line follower is supposed to follow a line which may be black or white. It depends upon your IR sensor and the coding that you are using. Either the IR sensor is active low or active high. Then the additions that were made to it were the sensing of voltage, the sensing of current, the storing of data in the SD card module, as well as showing it on the web server. And along with this, there was another requirement such as OLED display, which should show all the working constantly with the robot. As you can say that when the robot follows the line, it should show the voltage that it senses, the current it senses, and the turns it takes. Other than that, it should also show us the color of the object that's in front of it and avoid that object as well. So after this, there's some technical parts, and the work breakdown of our project was: first we made a rough code and some software of it. Using software was the Proteus to make the design, and we made the PCB design and the hardware. Then assembly and soldering. In the first week, we made rough design and some coding ideas from AI, and in the second week we used Proteus for designing. In the third week we etched the project, we were making the project, and the fourth week we completed the project and tested it. This part of the project was completed within a month, but it didn't include anything like the Wi-Fi modules or either the SD card or OLED display. A lot of parts were missing, so the final date that we submitted it was on 6th of May. So it took a lot more time than that. This is the starting estimate budget that we had, and it didn't include the other sensors. Then comes our introduction related to our main project. First of all, this shows that what is a robot and how it came into the light of engineering. So other than that, this part shows our own project that we started. It has Arduino Uno as a microcontroller and an ESP32 as a Wi-Fi Bluetooth module, and the coding was done on Atmel Studio. And then there is literature review, list of components. The components we used were IR sensors for light detection, current measuring using current sensors, and voltage sensor for voltage measurement, displaying data on OLED and storing data in SD card, measuring of speed and distance of robot using encoders, and ultrasonic sensors. Using ultrasonic sensors, we simply made a obstacle avoiding robot, and then there was ESP32 that was used to send data to cloud. We used ThinkSpeak for that. The data displayed on OLED, as prescribed already, was voltage sensor value, current sensor value, and so on. Over voltage value, current values, the obstacle it detects in front of it, the color of that obstacle, the turns it takes, were all stored in the SD card by using our code. Then there is the basic block diagram. In this block diagram we show that there is a power supply that goes to Arduino Uno. There is a voltage sensor, ultrasonic sensor as an input, SD card as an input, IR sensor as an input, and motor driver as an output that goes to the two DC motors that are added to it, which are the main source of its primary movement. Then there is the product design, and the criteria for this was to make as simple as possible and to use as small as possible, as it is a age of development where we try to compress everything to a minimal size. So to compromise that, we made sure to make a design that was very compatible to its size as well as to the components that we use to it. We also made sure that to make it budget friendly, so it can be used in larger scale as well. Then there is the mechanical design, that we made sure to give it a shape of a RC car, so that it can also resemble the cars and give a better design. Then there is electronics design and the sensor selections. So the component selection, we used Arduino Uno as as the number of pins that were required for this project was were already enough on Arduino Uno. We could have also used Arduino Nano, but Arduino Uno was used because we already had it from our previous projects, and the L298 motor driver was also used for the movement of motors. Encoders were also used. The chassis used was a two tires motor mounted chassis, and the ultrasonic sensors. Then there is the OLED current sensor module, SD card module, infrared, resistors, capacitor, diodes, and PCB board. The PCB board we used were two, and one was fiber and the other was a simple copper board. The diodes were used to avoid the reverse current so that the components are safe. The IR sensor we used were TCRT 5000 IR sensor, and these are shown over here. Basically the ones we used were active low, so whenever there was a black line, that means it had 0 as an input, then it would give a high output, that is 1 as output. Then there is ultrasonic sensor, we use SR04 ultrasonic sensor with trigger and echo as digital pins, and VCC and ground. And other than that, we have, this is the photo of the motor driver over here, and this is the data sheet of this motor driver. Then there is power supply requirements. For this motor driver we use 12 volt DC motors, and for the microcontrollers we used 5 volt regulated voltage. For that we also used a voltage regulator. And then there is current sensor, we use this current sensor, its model is ACS712 and it's shown over here. Then there is a voltage sensor that we use, and this is the Arduino node that we use. Software designing and user requirements. Then there is simulation, integration. The integration of the parts is shown over here. This is the schematic design of the basic module. Over here you see this 9 voltage battery, then this goes the power switch. These are the two IR sensors, the ultrasonic sensor. This is the SD card module. This is the current sensor module. This is the SD card module, the OLED display, motor driver, and two motors along with the voltage sensor. The ESP32 is not shown over here. I can also show its Proteus over here. So you can see this is the voltage sensor, this is the current sensor, ultrasonic sensors, and all the parts shown in those pictures. Other than that, we also added a diode over here after we realized that there can be a reverse current and our microcontroller can get burned, so we used a diode for reverse current. Then this is the PCB design, the PCB layout that we printed, and this is a 3D view. Other than that, we have this is the mechanical making of the project. This was the drilling part. This is the final product. Over here, this is the fiber board. The components are all detachable. We can remove this this Arduino Uno. The IR sensors are attached here. This is the place for ultrasonic sensor. This is for SD card. This over here is OLED. This is motor driver, and this is the regulator that I was talking about. This power button is the main power source. If we even if the battery is attached, when this power switch is off, the power supply won't go forward. After that comes the OLED part. Under this OLED there is a diode which stops the reverse current, so it's hid under it, so you cannot see it very particularly clearly. Then there is this final testing of all this. Other than that, this is the final look of our project with the components attached, the IR sensor, ultrasonic sensors, and the battery also. Up to this part was the part without the web server, without attaching any of those values to the server. Then we came up with the ESP32 part. This is the Proteus of ESP32. Just a second, yes. Over here this shows the color sensor, and these are some pins for the ESP32 module. This is the ESP that we used, and I'm gonna show you in a while. Yes, this is the ESP that we used, and the PCB design is also showed here. Over here. Okay, then the final is the execution. This shows the project budget and the finalization of the project. Initially it was 10K for our budget, then it jumped from 10K to in between 15 to 20K as per the requirements. And then these are some reference links that we used for buying the components and for our help in the project, and some website. The final project after the ESP32 module was this. You can see that these two are IR sensor. This is ultrasonic sensor. Over here is the SD card module, and this is the ESP32 module. Basically, in this project, we also made sure to make it as small as possible. Over here, there's supposed to be a color sensor which will be attached over this part with wires, and this is the voltage and current rating. We are gonna zoom it in a while. There you go. Over here you can see the voltage and current values, and over here is the voltage regulator part that was inbuilt. Over here was the current sensor part that was not inbuilt. The current over here is showing -14 because the wires are short at the moment without the current sensor. We have shown it without the current sensor. And over here is the final block diagram of our project. You can see that the 12-volt battery was given into the 5-volt regulator of for Arduino Uno, that went to the V in of Arduino Uno. Then there is the 3.3 volt V out that we used for powering up the ESP32, because ESP32 works in between 3 to 3.6 volts, that we had to use this output for ESP32 module. Other than that, for serial communication, we made sure that the ground of both the devices, both the microcontrollers, was common. The analog pins have IR sensors, voltage sensor, current sensor, ultrasonic sensor, and encoders attached to it. The motor driver needed 12-volt battery for its proper working, so we gave 12 volt directly to the motor driver, and the enable pins, input pins were all attached to this part, and the output pins of motor driver were attached to the left and right motors. Other than that, the display was attached to the pins of STI and STA pins, and the SD card module also had its own pins that were attached. Color sensor was attached to ESP32 module. How it worked was basically the robot was supposed to follow the line simply, and while following the line, if any obstacle was in front of it, it was supposed to sense the color of the project. If red, it should turn back and move in the reverse direction, and if black, it should stop at that moment. The whole process should stop at that moment. So for that we use TXRX as serial communication, and the color was sensed over here and sent to the Arduino Uno, and from there it was sent to the SD card, to the display, to the current sensors, to the IR sensors and ultrasonic sensors. All of this working was in sync with each other, and the baud rates were also set the same as 9600 BP per second. Okay, and that is bits per second. Other than that, there is the trigger and deco pin for ultrasonic sensor, and we can show you the working video of our project from over here. You can see, first of all, I like to show you the simple working video where you can see it's working without the line. So over here, when I put my hand over here, you can see this tire paused, and when I put our hand here, this tire paused, and they're both on my hand. That means the robot will move 360. It will rotate in one direction to sense the line again, to get on the path again if it's out of the path. Over here I can show you the working video on the line. So you can see this is the working on the line, and other than that, then there is my GitHub profile where I have posted this REHBAR project, and my LinkedIn profile. Just a sec before it's loaded. I have attached the report to this LinkedIn, and it's gonna show you in a while. Some internet issue over here. Yes, you can see this is my LinkedIn profile, and I've attached the file over here. It's taking a bit too long to load, so I'm gonna skip. And this is the GitHub profile. The requirements are all complete now, and I hope you like this video and you like my project. If any queries you have related to this project, you can ask me in the comment section, and I'll try my best to reply to you guys. And I hope so it resolves all the queries that you might have related to this project. And Allah Hafiz, see you soon.